Yes, good evening, students. So, in the previous chapter, we have started with haloalkanes and haloarenes. So, we have seen the MCQs, that is multiple choice questions, in the previous session. Yes, so these were the questions which we have discussed in our previous class. So, from this chapter, so the total marks for this particular chapter is 9 marks. So, in these 9 marks, so you'll be getting 1 mark, two questions. Okay, one will be a MCQ question, another will be a fill in the blank question. Then 2 marks, one question, and a 5 mark long answer you'll get. Okay, so this 5 marks you don't get a directly 5 mark question. So these 5 marks are further divided into 3 plus 2 questions. Fine. So these were the MCQs which we have discussed in our previous class. So now we'll see the fill in the blanks, okay, which we are supposed to do from this particular chapter. Okay, just a second. Okay, so as you know, so the answers you can answer me in the chat box. You can give your answers in the chat box. So from there, I'll be replying you. Okay, so we'll start with the fill in the blanks. So the fill in the blanks, the first one is the boiling point of isomeric haloalkanes decreases with increase in. Yes, so the boiling point of isomeric haloalkanes decreases with increase in. Okay, I've got the answer. Temperature. Vidya has answered is at temperature. What about others? What do you mean by isomeric? Now, when we are discuss about boiling point, okay, now just remember about boiling point. Now, boiling point. Okay, so lower alkanes. Okay, I'll change the color. Just a second. Okay. So I think now the screen is visible properly. Okay, fine. So now, okay. So the boiling point of isomeric haloalkanes. Now, when we are talking about boiling point, Okay, when we are discussing about boiling point, so what will happen to boiling point in case of haloalkanes? Okay, so lower haloalkanes. So as you are moving from lower haloalkanes to higher haloalkanes, okay, higher haloalkanes, what will happen to boiling point? Boiling point will increase. Okay, why the boiling point increases? Because with the increase in mass. So as you move further, okay, as you go from lower to higher, what will happen to the mass? The mass of the haloalkane increases. So what will happen to boiling point? Boiling point also increases. Remember this. Now, what will happen to this boiling point of isomeric haloalkanes? What do you mean by isomeric haloalkanes now? Yes, students, what do you mean by isomeric haloalkanes? Isomeric means when they are in branch form. Okay, when they are in branch form. So what will happen to boiling point of isomeric haloalkanes? What will happen to boiling point of isomeric haloalkanes? It decreases with increasing branching. So as you increase the branching, okay, remember that, see here, okay, what will happen? So now when you have a straight chain compound, suppose I have that is CH3Cl, okay, then I have CH3, CH2Cl, then I have CH3, CH2, CH2Cl, okay, I have taken the same. Now here, what is happening here? So the number of carbon atoms, okay, and hydrogen atoms are increasing in the subsequent molecules, okay, in the subsequent compound. So what will happen to the boiling point? Boiling point will increase. Now suppose I take CH3, CH2, CH2, CH3, okay, then the same CH3, CH2, CH3, okay, like this. So what will happen? CH3, 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 5 here, 5 it becomes. Okay. Hmm. So what will happen in this case? Yes, students, what will happen? So here you can see as the branching increases, okay, as the branching increases, what will happen? As the branching increases, then the boiling point of this isomeric haloalkanes will decrease, okay, with increasing branching. So as your branching increases, the boiling point goes on decreasing. The boiling point goes on decreasing. So when we are considering the straight chain compounds and branch compound, the branch chain compound will have boiling point lower. Okay, it will have boiling point lower, and in the straight chain compound, the boiling point will be higher. Okay, so this is the answer. So as because what will happen as in straight chain compounds, what will happen? There will be increase in size and mass of the halogen atom. Okay, so the magnitude of van der Waals forces also increases. But when we are talking about isomeric, okay, when you are talking with isomeric alkyl halides, so they decrease. So they decrease with the increase in the branching. So remember that. Fine. So next question A. A derivatives that is dash derivatives of methane and ethane are called as freons. Yes, which derivatives of methane and ethane are called as freons, students? Yes. Okay. Volatile. Type. Dash derivatives of methane and ethane are called as freons. What are called as freons? You have studied this in your theory, right? What are freons? What are freons? Freons are the chlorofluorocarbons. Okay. So they are called as chlorofluorocarbons. Okay, so the chlorofluorocarbons of that is the compounds of methane and ethane, they are called as what? They are called as the freons. So what are which derivatives? Chlorofluoro. The answer is chlorofluoro. So this is branching. The answer is branching. This is chlorofluoro. Chlorofluoro derivatives of methane and ethane are called as freons. Next, third one, dash mechanism have inverted configuration. Yes, so in this chapter you have two mechanism. One is SN1 and the other is SN2. So which particular mechanism have inverted configuration? Yes, we have studied what is racemic mixture, what is retention, what is inversion. So can you tell me which particular mechanism will have an inverted configuration? Yes, Vedvati, Nikita, Chetan. Yes, have answered it right. It is SN2. Good. Okay, so it is SN2. So S, so substitution, nucleophilic, bimolecular. Okay, so SN2 mechanism, it has a inverted configuration. Good. So moving further, next question. Freon 12 is, what is Freon 12? What is Freon 12? What is the formula of Freon 12? What is Freon 12? It is CCl2F2. Okay, that is chlorofluorocarbon. So this is a chlorophore that is a chlorofluorocarbon with the chemical formula is CCl2F2. Okay, CCl2F2. Next one. Dehydrohalogenation of ethyl chloride is an example of dash reaction. Yes, dehydrohalogenation means elimination of hydrogen halide. Okay, elimination of hydrogen halide of ethyl chloride is an example of what? So dehydrohalogenation of ethyl chloride, that is CH3Cl. Okay, so from ethyl chloride. So it is an example of what? Dehydrohalogenation of ethyl chloride. What particular example it is? Yes, we have studied this, right? Mm, it is a elimination reaction. Yes, is it not elimination reaction? Elimination reaction. See here. C. Okay. So what is happening? Hydrogen and Cl will form your. Okay. So what is happening here? So there is elimination of hydrogen chloride. Okay. So it is a elimination reaction. So dehydrohalogenation is an example of a elimination reaction. Okay. Next question. IUPAC name of tertiary butyl chloride is. So what is the IUPAC name of tertiary butyl chloride? Yes, how is the structure of tertiary butyl chloride? Yes, what is the IUPAC name of tertiary butyl chloride? Yes, this is the structure of tertiary butyl chloride. Okay, your carbon has three other carbon atoms and a chlorine atom. So it is a tertiary butyl chloride. So what is the IUPAC name of this particular compound? Yes, IUPAC is very important. So 1, 2, 3. So if I give the numbering like this, 1, 2, and 3. So what it will be? 2 chloro. Is it 2 chloro? Okay. 2-methyl propane. Is it so? Okay, 2-chloro, 2-methyl propane. Yes, Netravati has answered it right. It is 2-chloro, 2-methyl propane. Okay, so 2-chloride, 2-methyl propane. So see here, 1, 2, 3. So at 2 position you have chloro, at 2 position you have methyl. So 2-chloro, 2-methyl, because chloro comes first, C comes first, and then comes your M. So 2-chloro, then 2-methyl, and 3 carbon atom as parent chain. So it is 2-chloro, 2-methyl propane. Okay, 2-chloro, 2-methyl propane. Fine. Fine. Sorry for the interruption. So we'll continue now. Okay. So the next question which we were discussing was alkyl halides are formed when dash and alcohols are refluxed in the presence of pyridine. Yes, alkyl halides are formed when alcohol. So alcohols, if you, so the answer is thionyl chloride. Okay, what is the answer? Thionyl chloride. So if when you refluxed, okay, when you reflux your, so it is thionyl chloride. What is thionyl chloride? Right. So SOCl2. So alkyl halides are formed when thionyl chloride and alcohols are refluxed in presence of pyridine. Remember this? Okay. So alcohols, if you reflux it with thionyl SOCl2 in the presence of pyridine, you get RX. You get RX. Okay. Plus side products are formed. That is SO2 plus uh, HCl gases. Okay, so these two are gases. So these are liberated. Fine. Next question. The common name of alkyl magnesium halide is. What is the common name of alkyl magnesium halide? Alkyl magnesium halide. RMgX. Yes, what it is called as? Alkyl magnesium halide. What it is called as? Alkyl magnesium halide. Okay. Vedvati, Priyanka, yes. It is called as Grignard reagent. It is called as Grignard reagent. What it is called as? Grignard reagent. Good. Okay. The answer is right. It is Grignard reagent. What is? So the common name of alkyl magnesium halide is Grignard reagent. Fine. Good. Moving further, next question. Grignard reagent reacts with any source of proton to give. Yes, Grignard reagent reacts with any source of proton Yes, the objects which are non-superimposable on their mirror images are called as. What are the objects which are non-superimposable mirror images? What they are called as? They are called as. Yes, students, what they are called as? The objects which are non-superimposable on their mirror images. They are called as. Yes, they are called as chiral molecules. Good. They're called as chiral molecules. So chiral molecules. So what are chiral molecules? Yes. So with these are non-superimposable on their mirror images. Fine. Good. Next question. Ethane nitrile can be prepared by heating dash with alcoholic KCN. So ethane nitrile. So ethane nitrile can be prepared by treating with alcoholic KCN. What is ethane nitrile? What is the structure of ethane nitrile? So it will be CH3C triple bond N. Right. So this is ethane nitrile. Fine. So ethane nitrile if it can be treated. So how this can be treated? If you treat it with, so if you treat your methyl, this what methyl chloride. So if you treat methyl chloride with alcoholic KCN, okay, if you treat it with alcoholic KCN, then you can obtain your methyl uh, that is ethane nitride. Okay, you can obtain your ethane nitride. So this is the, so what is the answer? If you heat it with methyl chloride, the answer is methyl chloride. So ethane nitrile. So this can be prepared, your ethane nitrile can be prepared by treating your methyl chloride with alcoholic KCl. Okay, so this is the answer. Moving further, option the 12th question. Dash is used as an anesthetic during surgery. So for anesthetic, okay, for numbing your body. So when the operations are doing, you the anesthesia, they it is used. Okay, so which it is? Yes, it is halothane. Okay, halothane. Correct. Good. Halothane. So HA, the spell, just see the spelling HOLOTHANE. Okay, halothane. So halothane, it is right. So halothane, it is used as an anesthetic, okay, during the surgery for numbing your body. So next question, the process of conversion of dash into racemic mixture is known as racemization. The process of conversion of dash into racemic mixture is known as racemization. Yes, how, what is it? Enantiomers. Yes, Vidya has answered it right. It is enantiomers. The process of conversion of enantiomers. Okay. So when you're converting your enantiomers into racemic mixture, it is called as what? It is called as racemization. It is called as what? Racemization. Yes. Vedvati Vidya has answered it right. It is enantiomers. Good. Okay. Next question. The poisonous gas dash is formed when chloroform is exposed to air and light. Yes, the poisonous gas is dash is formed when chloroform is exposed to air and light. So which is the poisonous gas which is formed when chloroform is exposed to air and light? It is Important, very important. Yes, good. So Sita, Vedvati, Chetan Gowda has answered it right. It is phosgene. Okay, the answer is phosgene. It is phosgene. Okay, so the poisonous gas phosgene is formed when chloroform is exposed to air and light. Next question. Meso compounds are optically inactive. Why meso compounds are optically inactive? Due to dash. Yes. Why meso compounds? What are meso compounds? What are meso compounds, students? What are meso compounds? So when you introduce a plane of symmetry here, so one half of the molecule is equal to the other half. So these are called as meso compounds. So why they are inactive? It is due to plane of symmetry. So because of the presence of plane of symmetry, meso compounds are optically inactive. Okay. Next question. SN1 reaction proceeds through dash formation. So SN1 reaction proceeds to dash formation. So how the SN1 reaction? So we have discussed about SN1 reaction and SN2 mechanism, right? So again, SN1 reaction, it proceeds via two steps. So first step is what? It proceeds to a carbocation formation. Okay, the answer is carbocation formation. So SN1 reaction, it proceeds through carbocation formation. Is it right? So these were the some of the fill in the blanks, okay, from this particular chapter. I hope it is clear. Okay. So moving further, we'll start with the 2 marks question. So there are some 2 marks question. So we'll discuss them. So in 2 marks question, so in this from this particular chapter, most probably all are the name reactions. Okay, all are the name reactions which we are going to discuss. So the first question is explain Darzin's reaction with an example. So you have to explain a Darzin's reaction with an example. Yes, students. So what is Darzin's reaction? Yes, what is Darzin's reaction? Do you know what is Darzin's reaction? So very important name reaction. So please mark it important. So from 2 marks reaction, all the named reactions from this particular chapter are very important. Okay. So write it down. So as I've told you in my previous classes that take a writing pad and a pen, okay, so that you can write some important points from that. Okay. So what is Darzin's reaction? Okay. So when you react it with thionyl chloride, so that is alcohols are reacted with thionyl chloride in the presence of pyridine. Okay, giving you alkyl halides, alkyl chlorides, okay, plus SO2 gas plus HCl. So this is a Darzin's reaction. So this is example is very important. So a general reaction and one you can use methane alcohol plus thionyl chloride, okay, pyridine. Then what you'll get? CH3, Cl plus SO2 plus HCl. So one general reaction and one example. So you have to study. Study. Okay. So this is about Darzin's reaction. Fine. So what is the explanation you have to write now? So alkyl chlorides are prepared by refluxing alcohols with thionyl chloride in the presence of pyridine. Okay. And this is called as Darzin's reaction. Fine. And you have to write this example. So if they tell you write an example, you have to write this example. Okay, particular example. If they tell you to write a general reaction, then you have to mention this only. Okay. So please study the general reaction as well as the example. Okay, from Darzin's reaction. So for all the name reaction, you have to learn the general reaction as well as one example. Okay. So this is Darson's reaction. So one more time I'll repeat. So alkyl halides are alkyl chlorides. Alkyl chlorides can be prepared by refluxing alcohols with thionyl chloride in the presence of pyridine. Okay. This is called as Darson's reaction. So this is the first question. Okay. Is it clear? Yes. Is it clear? Is it clear, students? Yes. Okay. Fine. Next question. Explain Finkelstein reaction with an example. Okay. Explain Finkelstein reaction with an example. So what is Finkelstein reaction? Finkelstein reactions. Okay. These are the best reactions for preparing your iodoalkanes. So from these reactions, Finkelstein reactions are used for preparing your iodoalkanes. So iodoalkanes can be prepared. Okay, how they can be prepared? They can be prepared by reacting your by the reaction of alkyl fluorides. So by reacting your alkyl chlorides or alkyl bromides with sodium iodide in the presence of dry acetone. Okay, in the presence of dry acetone, you get iodoalkane. So this is the statement. So one line, whatever the reaction you are writing, for that you have to give the explanation. Okay, that is iodoalkanes can be prepared by the reaction of alkyl chlorides or alkyl bromides with sodium iodide in dry acetone. Okay, in dry acetone. So this is the particular reaction. Now, so this is the general equations. I'll take an example. So if I take ethyl, okay, CH2, C2H5, ethyl chloride plus sodium iodide. So in the presence of dry acetone, I'll get what? Yes, what will be my product? What will be my product? Yes, Prithviraj, it is correct. Okay, your alkyl halide will be your chloride or bromide, RX. Okay, your RX can be RCl or RBr because X can be your iodide also. But from Finkelstein reaction, we are preparing only iodoalkane. So your X cannot be this what iodo. So what will be the answer here now for my question? So the answer is C2 H5I, that is ethyl iodide plus sodium chloride. Okay, so ethyl iodide. So ethyl iodide and sodium chloride. Good. So yes, I've got the answers. Yes, good. Prithviraj, Priyanka, Vedvati. Yes, good. The answers are right. Fine. So, so you need to, as I've explained you, so please explain the name reaction, write the example. Example is important. So for example, 1 mark. For your explanation, 1 mark. If you don't explain, okay, then your own, if and your example is right, you will get only 1 mark. If you write the example, but your what not explained it, then your 1 mark will be deducted. Okay, so like that. So for explanation, 1 mark, and for example, 1 mark. And see that you write the names. Okay, so in your previous, how it was, so ethyl chloride plus sodium iodide. So in the presence of dry acetone, write the solvents also. Okay, then it will be ethyl iodide plus sodium chloride. So you have to write the names here. Sodium chloride. Okay, so this will be ethyl iodide like this. So you have to write the complete names also, so that this will attract the examiner. Okay, this will attract the examiner. So please provide the names also. So if you write the name, then the examiner will be happy with your answer. Okay, so this will be a complete proper way of writing the examples. Fine. So moving further, next question. Explain Squat's reaction with an example. Okay, explain Squat's reaction with an example. So what is Squat's reaction? Yes, what is Squat's reaction? So in Squat's reaction, you can prepare your fluoroalkanes. Okay, so fluoroalkanes, fluorocompounds. Fluorocompounds can be prepared. Okay, fluorocompounds can be prepared from this particular reaction. So fluorocompounds are prepared by heating alkyl chlorides or alkyl bromides. So you can prepare your fluorocompounds. Alkanes can be prepared by heating your alkyl chlorides or bromides with silver fluoride. Okay, so I'll give you example for this Squat's reaction. Okay, I'm writing the Squat's reaction. So I can take methyl bromide and silver fluoride. Okay, you have to heat this. You have to heat this. You get methyl fluoride plus silver bromide. Okay, so you can write here methyl bromide. Okay, or bromomethane. This is silver fluoride. This is fluoromethane. So fluorocompounds. So from this particular reaction, what is formed? Fluorocompounds are prepared. Okay, alkanes are prepared. So what is Squat's reactions are prepared by heating an alkyl chlorides or bromides with silver fluoride. Okay, so fluoroalkanes can be prepared by heating an alkyl chlorides or bromides with silver fluoride. Okay, so this is a particular example. Okay, so we'll go for the next question. Explain Sandmeyer's reaction with an example. Okay. Okay. So what is Sandmeyer's reaction? Yes, students, what is Sandmeyer's reaction? So chlorobenzene and bromobenzene, okay, it can be prepared by treating your benzene disonium salt. Okay, this is benzene disonium salt, that is N2Cl. Okay, benzene disonium salt. Okay, so benzene disonium salt, that is benzene disonium chloride with cuprous chloride, that is Cu2Cl2 in the presence of HCl, giving you chlorobenzene. Okay, giving you chlorobenzene plus N2. Giving you chlorobenzene plus N2. Fine. So this is your Sandmeyer's reaction. So what is the example of Sandmeyer's reaction? So chlorobenzene or bromobenzene, okay, can be prepared. So if I take here chlorobenzene, I want to prepare chlorobenzene, then I have to take here cuprous chloride. Okay. If I want to prepare my bromobenzene, I have to take here cuprous bromide, Cu2 Br2. Okay, Cu2 Br2. Fine. So chlorobenzene or bromobenzene can be prepared by treating the benzene disonium chloride with cuprous chloride in the HCl, okay, or cuprous bromide in HBr, Cu2Br2 in HBr. So if I want to prepare bromobenzene, fine, plus N2 will be formed. So this is Sandmeyer's reaction. Okay. Next question, explain. So before going to Wood's fatigue reaction, first I'll explain you what is Wood's reaction. Okay, first we'll see. So we have seen these questions. So now we'll see the sixth one. Okay, Wood's reaction. What we are seeing is explain Wood's reaction. So what is Wood's reaction, students? What is Wood's reaction? Wood's reaction. So alkyl halides. Okay. So when Rx plus I'll take it like this. 2Rx plus 2Na in the presence of dry ether gives you RR plus 2NaX. So this is our which reaction? Woods reaction. So what is the explanation? Alkyl halides react with alkyl halides react with sodium in the presence of dry ether to form higher alkanes. Okay, so this is the general reaction. 2Rx, this is alkyl halide. So alkyl halide is reacting with your sodium metal in the presence of dry ether, giving you alkanes. Okay, higher alkanes. I can give you example as I'll take methyl bromide. Okay, I'll take methyl bromide plus 2Na plus CH3Br. Okay, so what will happen here? BrCH3. So if I take like this, okay, so what will be my product, students? So this is eliminated. Okay, this in the presence of dry ether, giving you what? CH3, CH3 plus 2NaBr. Is it correct? Yes. Is my reaction correct? So alkyl halides. So alkyl halides, they react with sodium in the presence of dry ether to give you higher alkanes. Okay. So higher alkanes are formed. So methyl bromide, two molecules of methyl bromide reacting with sodium in the presence of dry ether giving you ethene. Yes. Is it clear? Is Wood's reaction clear? So please study the general reaction. So this is the general reaction. Please study the general reaction as well as the example. So this is a example. Okay. Example and general reactions are very important. Please study both the things. Okay. Next question. Explain fatigue reaction. Now we'll see explain fatigue reaction. What is fatigue reaction? Yes, what is fatigue reaction? Aryl halides. Okay. Aryl halides, they react with sodium metal. Okay. To give in the presence of dry ether, in the presence of, I'll write the reaction. Okay. So aryl halide. So I take an example of aryl halide. So I'll write the general equation first. So aryl halides, when it react with sodium metal, okay, in the presence of dry ether, what I'll get? What will be the product, students? Is it right? I get a diphenyl. I'll get a diphenyl. Is it right? Yes. Is it right? Fatigue reaction. I'm talking about fatigue reaction. So remember that in Wood's reaction, we are taking alkyl halides. We are taking alkyl halides. Okay, in Wood's reaction, two molecules of alkyl halide. In fatigue reaction, we are taking aryl halides. Okay, so here what is happening in fatigue reaction? Aryl halides react with sodium metal, okay, in the presence of dry ether to give you diphenyl, to give you diphenyl. So I'll give you example. So what will be the example here? I'll take your bromobenzene plus 2Na plus in the presence of dry ether. Yes, what will be the answer? It will be diphenyl plus 2NaBr. Right? Is it right? Yes. So this is our Fittig reaction. Yes, this is our Fittig reaction. Now I've explained you both. I've explained you both. I've explained you Wood's reaction also. I've explained you Fittig reaction also. Now, can you tell me? Can you tell me what is Wood-Fittig reaction now? Yes, students, can you tell me what is Wood-Fittig reaction? Can anyone tell me what is Wood-Fittig reaction? I have explained you what is Wood's reaction. I have explained you what is Fittig reaction. Now I want from you all what is Wood-Fittig reaction. Yes, anybody? What is Wood-Fittig reaction, students? Okay. Coupling reaction to aryl halides. Okay. Is my reaction right? Yes, is my reaction correct? I've taken one aryl halide. I've taken one alkyl halide. Okay. So I'll explain now. Okay. So when a mixture of, okay, read the statement. When the mixture of alkyl halide and aryl halide. So when a mixture of alkyl halide and aryl halide are heated, okay, they are heated with sodium metal. They are heated with sodium metal in dry ether medium. Okay, in dry ether medium, then alkyl arene is formed. Alkyl arene is formed. So what is the product form? Alkyl arene. What is the product form? Alkyl arene. Okay. So this is our Woods-Fittig reaction. So in Wood's reaction, we are taking two alkyl halides, two molecules of alkyl halides. In Fittig reaction, we are taking two molecules of aryl halides. Okay. So in both the conditions, we are reacting it with sodium metal in the presence of dry ether. But in Wood's Fittig reaction, we are taking one alkyl halide, one aryl halide. Okay. We are reacting, we are heating it with a dry, sodium metal in the presence of dry ether, and what we obtain, what is the product? It is alkyl arene. Okay, it is alkyl arene. Fine. So this is the Woods-Fittig reaction. I hope these 7 questions are clear. Yes, any doubts still here? Students, any doubts still here? 7 questions. We have completed these 7 questions. Any doubts? Okay. So we have completed 7 questions. Okay, up to 7 questions. So next, explain Friedel-Crafts alkylation reaction of chlorobenzene. Yes, I hope you are writing the things. Yes, I hope you are writing the things. Explain Friedel-Crafts alkylation of chlorobenzene. Okay, so please write down the reaction. The reaction will be like this. Yes. So chlorobenzene, this is 1 chloro, 2 methyl benzene, and this is 1 chloro, 4 methyl benzene. Okay. Yes. Tell me now. So this is alkylation. Okay. Alkylation reaction. Alkylation. We are doing alkylation. So I'll give the statement chlorobenzene. So this is our chlorobenzene. So chlorobenzene reacts with methyl chloride. Chlorobenzene reacts with methyl chloride in the presence of anhydrous AlCl3. Okay, in the presence of anhydrous AlCl3, that is aluminium chloride, to form ortho and para products. So this is a ortho product, this is a para product. You know what is ortho substituted. So 1,2 position is called as ortho substituted and 1,4 position is called as para substituted. Okay. So this is Friedel-Crafts alkylation reaction of chlorobenzene. Okay. Now the next question is explain Friedel-Crafts acylation. Acylation is different, alkylation is different. So read the question properly and then answer. Okay. So explain Friedel-Crafts acylation reaction of chlorobenzene. So I'll do the changes here itself. Okay, I'll do the changes here itself. But this is the next question. Okay. 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 Are you writing them? Yes, write the reaction. Okay. So this is acylation. Okay. Just now we have completed the reaction that was for alkylation, Friedel-Crafts alkylation reaction on chlorobenzene. Now the reaction which we are checking, it is on Friedel-Crafts acylation. Okay. Like I'll explain this reaction. So chlorobenzene, when it reacts with acetyl chloride, this is what? This is acetyl chloride. So chlorobenzene, when you are reacting with acetyl chloride in the presence of anhydrous aluminium chloride, okay, in the presence of anhydrous aluminium chloride to give you ortho and para products. So which are the ortho and para product? One is 2-chloroacetophenone and the second one is 4-chloroacetophenone. So this is a ortho product, this is a para product. Okay, 1,2 substituted and this is 1,4 substituted. So Friedel-Crafts alkylation is another question and Friedel-Crafts acylation is another question. Understood? Are these two questions clear? Yes, are these two questions cleared? Okay, fine. So moving further, next questions. What is chirality? Okay, so these are 1 mark questions. What is chirality? So chirality is one question, 1 mark question. So uh, what is chirality? What is chiral carbon? Okay, I can take it as uh, okay, what is chirality? Yes, students, what is chirality? What is chirality? So it is a property of a molecule to have non-superimposable mirror images is called as chirality. Okay, what is chirality? The property of a molecule to have non-superimposable mirror image is called as chirality. Okay, so this is chirality. Understood? Okay. Now, next is what is chiral? What do you mean by chiral compounds? What do you mean by chiral compounds? What do you mean by chiral compounds? So chiral compounds are those compounds to which the carbon atoms are attached to four different atoms or molecules. Okay, they are attached to four different molecules, atoms or molecules. Then it is called as chiral carbon. So what is chiral carbon? So the carbon to which four different atoms or molecules are attached. Okay. Next is racemization. What do you mean by racemization? Yes. What do you mean by racemization? What do you mean by racemization, students? What do you mean by racemization? The process of conversion of enantiomers into racemic mixtures. What is racemization? So it is the process of conversion of enantiomers into a racemic mixture is called as racemization. Okay. Next is enantiomers. What do you mean by enantiomer? What is the meaning of enantiomer? What is enantiomer? So enantiomers are optically active isomers. Okay, enantiomers are optically active isomers which are non-superimposable. So non-superimposable isomers. Okay, so these are the stereoisomers which are non-super imposable. Okay, non-superimposable mirror images. So they have non-superimposable mirror images of each other are called as enantiomers. So I'll repeat one more time. So the optically active isomers which are non-superimposable mirror images of each other, okay, are called as enantiomers. Okay, are called as enantiomers. Next is what is racemic mixture? Give an example. Yes. What is racemic mixture? Give an example. So what is racemic mixture? So what is racemic mixture? So it is a mixture which is containing two enantiomers in equal proportions. Okay. So 50% inversion and 50% retention. Okay. 50% inversion, 50% retention. So it is a mixture which is containing two enantiomers in equal proportion. So a mixture which is containing two enantiomers in equal proportion, that is equimolar mixture of D and L isomers. Okay, equimolar mixture of D and L isomers are called as racemic mixture. So, example, okay, so for definition, 1 mark, for example, 1 mark. So, plus and minus lactic acid, or I can write it as DL, okay, DL lactic acid. Fine. So, this is about racemic mixture. Is it clear? So we have discussed 11 questions. Okay, we have discussed 2 marks questions, that is 11 questions. So we have left with some more questions. So these questions I'll take in the next session. Okay, any doubts? Any doubts for whatever has been taught till now? Any doubts? So we have covered MCQs question. We have covered the fill in the blanks. Okay. And we have covered some of the short answers. So we have left with few questions. Okay. So that we'll be discussing in the next class. Any doubts, students? So if you have any doubts regarding the, you can ask it in the chat box. You can drop your messages in the chat box. Any doubts? Fine. So if there are no doubts, okay. So please go through the previous sessions. Okay, the students who are new to the session. So please go through the previous sessions wherein we have completed the solution chapter, okay, electrochemistry chapter, and haloalkanes and haloarenes one class. Okay. So please go through the classes which have been covered. Okay. So in the next class, we'll be continuing with the same topic, that is haloalkanes and haloarenes. So I'll end the session here. So we'll meet in the next class. Thank you, dear students. Have a good day.